Hi everyone, my name is Shayla Davies, and today we're going to be doing a little bit of time traveling. But first, we need to learn a little bit before we can go on our journey, okay? Now we're going to be talking about the difference between a physical and a chemical reaction. So let's start with a physical reaction, shall we? So, a physical reaction is going to be something where the change is happening to the physical attributes of the object. So it's going to be a difference in the size or the shape. It's not going to be an actual change in the chemical makeup of the object. We're not changing what it actually is. It's mostly the size, the shape, and it's usually something that's reversible. So we're talking like turning water into ice. You freeze it, but it's still water, right? Yeah, does that kind of make sense? Now, a chemical reaction is a little bit more complicated. So a chemical reaction is going to be the rearrangement of the atoms or the molecules inside of the actual object. So we're taking our object and we're adding something to it, or we're changing the chemical makeup of what's inside of it. This is something that's usually irreversible, which means you can't bring it back to its original state, and it usually has to do with something being changed into something new. So we're going to put this right over here. Let's see a couple examples of both, okay? So here I have some pieces of colored paper. Now you can crumble up the paper, you can rip the paper into a bunch of tiny pieces, or you can even cut the paper. Now I'm not changing the color, the thickness, or what paper it is. It's still paper, right? But by changing the physical makeup of it, you can make it something a little bit more fun. Now, let's move on to the chemical, shall we? So we have a tall glass and a little bit of baking soda and some apple cider vinegar. Now, have any of you guys ever built a volcano for a science fair project? Okay, perfect, a lot of you have, great. Now, what happened when you put the two items together, the vinegar and the baking soda? It made an explosion, right? And it was pretty cool, wasn't it? Now, let's mix these two things together and see what happens, shall we? All right, okay, is everyone seeing what's happening? Okay, perfect. Now, this is an example of a chemical reaction. Now, it's also a physical reaction, right? Because we're seeing something happen, something is changing. But the bubbles are happening, we've mixed the liquid with the powder, and we can't bring these two things back to what they were originally, right? We can't put them back in their original state. So this is a chemical reaction. We've changed the chemical makeup of these two items and made something totally new, right? Now, let's move on and let's do a little bit of time traveling, shall we? We're going back to the Mesozoic era when dinosaurs roamed the earth. And I have here with me about half a cup of really, really hot water. Now this is hot, so hot it's boiling water, and we need to be really, really careful. So everybody make sure that we're being extra safe. We've got a spoon for a little bit later, and my favorite treat when I was a kid, dinosaur egg oatmeal. Now inside of here we have some dinosaur eggs, and there might be a couple of dinosaurs inside, but we're gonna have to check and see, okay? Now we're gonna mix this hot water with the oatmeal. Now, who thinks that this is going to be a physical reaction? Okay, I'm seeing a couple of hands. Okay, great. Now who thinks it's going to be a chemical reaction? Okay, a couple more people, so we're seeing a little bit leaning towards the chemical, yeah? Now, these dinosaur eggs are made of sugar. So when we mix the water with the sugar, we're gonna have to see what happens, okay? And then we'll kind of talk about whether it's a chemical or a physical reaction. So let's get started, shall we? We're going to very, very carefully mix our hot water in here. Okay, perfect, wonderful. We're gonna give this a quick stir. All right, I see something happening now. Everybody moving really close, okay? Now, inside of here, we've got a couple of changes happening. Now, we see that it's a little more liquidy, right? It's starting to look like actual oatmeal. And if you look really, really closely, you can see that we have all kinds of little colorful dinosaur eggs popping out of there, yeah? So the dinosaurs are starting to come out, they're starting to show. Now, how did this happen? The eggs were made of sugar, right? So when you have an egg made of sugar and you mix it with water, it's going to dissolve. Now that means that it's diluting, it's getting less and less potent. The sugar is spreading out into the water, right? Now this means that we're changing something, right? So now is this a physical or a chemical change? That's the question. Now we're adding the hot water and it has to be hot. If it's cold, this reaction wouldn't happen. So when the sugar dissolves, it is a physical reaction. Now I see a lot of you guys are kind of questioning. Now we're going to talk about why. Now it's a physical reaction because we're not changing the sugar into anything else. Yes, we're mixing it, we're adding two things like we did with the vinegar and the baking soda, but we're not changing the sugar into something else. The sugar isn't becoming salt, for instance, just because I added water to it. It's still sugar, it's just liquidy sugar. And yes, we do have a new item, don't we? That's right. The dinosaurs are revealing themselves, and they were inside of the egg, so that's kind of a new creation, right? So that's kind of what happens in a chemical reaction, but it was already inside, and we're not creating something new out of two things combining. Does that kind of make sense? Yeah? Awesome. Now, let's review a little bit of what we did today. So we learned a physical reaction has to do with the change in the appearance, the look of it, the size, the shape, that kind of thing. And the chemical change is going to be the actual molecular anatomy of that item is changing. Now, you know what we've also learned today? We have also learned that science can be pretty sweet.